Hi there, welcome back. Okay, we are on page 42, lesson 1.6, properties of integer exponents. You can do these and write these down with me as I go through them. So there's 4 properties that we're going to look at, and I'm going to just break them up into 4 corners. Okay, so let's look at this first one, product of powers property. Okay, so basically this says if you're in a multiplying problem and you have the same base, you're going to keep the base and add your exponents. So for example, if you have 7 to the 12th times 7 to the 4th. Okay, notice the bases are the same in this multiplying problem. So you're going to keep the base and you're going to add your exponents. 12 plus 4 is 16. So 7 to the 16th. Okay, so power of a power property, when something already has a power, when you're finding a power of something that already has a power, you keep the base. Keep your big base and multiply your exponents. So for example, if you had 7 that's squared, 7 squared to the 4th power, so a power of something that already has a power, you're going to keep the base and multiply your exponents. 4 times 2 would be 8. 7 to the 8th would be your final answer. Okay, let's take a look at these last 2 properties. Okay, so when your bases are different, you're going to multiply the bases this time and keep the exponent. So for example, if you had 7 squared times 4 squared. Notice the bases are different, but the exponents are exactly the same. So this time you're going to multiply your 2 bases, so 7 times 4 is 28, and you keep your exponent, so 28 squared. Last one is the quotient of powers property. So this time when the bases are the same, you keep your base and you subtract your exponents. This is now a division problem. So let's say you had 18 to the 9th divided by 18 to the 4th. Okay, so in a division problem, when your bases are the same, you keep the same base and you subtract. 9 take away 4 would be 5, 18 to the 5th. Now, division also looks like a fraction. So if you had 18 to the 9th on top and then 18 to the 4th on bottom, that's division. So the bases are the same, you keep the same base and you subtract. 9 take away 4 would be 5. Okay, so it could look either way. Okay, and one more important thing, just know that anytime you see a number without a power, it's always to an invisible 1. It's always to the power of 1. Any number that does not have a power showing, an exponent showing, is always an invisible 1. Okay? Okay, so let's move on over to page 43 and we will do a few in practice, okay? So this is multiplying the same base. You keep the base and you add your exponents. 8 plus 4 would be 12. Okay, so now this is finding a power of something that already has a power. Again, you keep your base of 3 and you multiply your exponents this time. So 5 times 4 would be 20. Okay, let's take a look at these right over here. This is dividing the same base. Keep your base and subtract your exponents. 7 take away 3 would be 4, 8 to the 4th. And now this time your bases are different in this multiplying problem. So you're going to multiply your 2 different bases. 3 times 2 is 6, and keep that exact same exponent of 9, 6 to the 9th power. Okay, let's take a look at number 14 right underneath it. So which expressions are equivalent to 2 to the 11th? Select all that apply. So what we have to do is solve all these and see which one equals 2 to the 11th. So now, dividing the same base means you keep your base and subtract. 23 take away 12 would be 11. So that definitely is equivalent. Okay, so multiplying the same base means you keep your base and add your exponents. 7 plus 4 is 11. Okay, that works as well. Again, dividing the same base means keep the base and subtract. 9 take away 2 is 7, so that one I would not mark. And then multiplying the same base means keep the base and add your exponents. 2 plus 9 is 11, so that one is equivalent as well. Okay, let's practice just a few more down below. So number 15. So you are finding a power of something that already has a power. So remember, you keep your base and you multiply the exponents. 3 times 4 is 12. On this one, if the bases are the same in a multiplying problem, you keep the bases and you add your exponents. 5 plus 2 is 7. Okay, let's take a look at these 2 over here. Dividing the same base means keep the base and subtract. 12 take away 3 is 9. Subtract your exponents. And then multiplying different bases means you're going to multiply your bases. 6 times 2 is 12, and keep that exact same exponent that they both share, 12 to the 4th. Okay, let's turn our page and do a few on the back side. Number 20. Let's take a look at number 20. It says, is this expression equivalent to this expression? Are these equal? Okay, well, one thing I want to point out is anything that doesn't have a power showing, write that 1 in. There's always an invisible 1 to anything that doesn't have a power. Showing anyway. This does have a power. It's an invisible 1. Okay, so now this is multiplying the same base. So remember, you keep your base and you add your exponents. 1 here plus 5 here would be 6. And now this one, remember when you're, actually you could do this 2 different ways. So you could solve the inside. So remember, you keep your base and you add your powers. 1 plus 1 is 2. So that would still be in parentheses to the 5th power. And then now this is finding a power of a power. So you keep the base and you multiply. 5 times 2 is 10. So these are not the same. So these are not equivalent to each other. Okay, so let's try this one over here. Now, in your book, it might show that one of these are negative. It might show one of these are negative. I'm not sure. Let's pretend we have one of these negative numbers outside. So let's see if these were equal to each other. So keep the base and you multiply. 2 times a negative 3 would be negative 6. Keep the base and multiply. 3 times a negative 2 is negative 6. So these are equivalent. And I just wrote that negative in case they were both negative in your book. Okay, so now one of the things that I want to look at is this one right here, number 25. Everyone take a look at that one. So this is 3b inside to the 5th power. Okay, so now I'm going to rewrite this 3 to the 1 power and b to the 1 power. Both of these there's 2 different bases inside, and remember, they're not showing a power inside, so there's an invisible 1 there. Okay, so now power of something that already has a power means you're multiplying. So keep the base of 3 and multiply. 1 times 5 would be 5. Keep the base of b and multiply. Power of a power. 1 times 5 is 5. So basically each one of these got that power of 5. And then 3 to the 5th, you could actually even take it a step further and multiply all that. Okay, I hope that helps.